They're not even. All right. So we're going to start with 2.68, equations involving the absolute value function. Okay. All right. So first thing remember is that absolute value means you're asking what is the distance from 0, right? And distance is always going to be positive. Distance is always positive. Okay. If I'm asking you what's the distance, just because I walk backwards, I'm just an idiot who walked backwards and probably ran into something, but I walked 3 feet backwards. Okay. I didn't walk negative 3 feet. Okay. All right. Distance is always positive. And that's what absolute value is telling you, is that even though it's a negative in the bars, I'm asking you how far is it from 0? So it's going to always produce a positive. Okay. Think about it as prison. The numbers go into jail and they're supposed to come out positive and reformed. Okay. Don't get it? Like, you know, people go to jail. The purpose of jail is to reform them, make them a better person. So when they come out, they be a positive and productive citizen. But that's the purpose. That was the reason. Okay. All right. Anyways, so we're here. We're in equations involving absolute values. If A is positive real number, there's going to always be 2 possible solutions, because there's going to always be 2 numbers that are the same distance from 0. So in your first little box, you're writing this. You're writing the absolute value of U, any number, equals A. And A can be positive or negative as a result. All right. Do we remember that? No, you do. Okay. 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 All right, let's do an example. So we're going to solve algebraically and then we're going to solve graphically, okay? Which is what we did both last year. So it's going to be kind of quick. All right, algebraically, when you have an absolute value equation, you're going to remove the absolute bars and you create 2 problems, right? So you're going to have x plus 2 equals positive 5, and you're going to have x plus 2 equals negative 5. Is that ringing some bells? Okay. All right, and your goal is to get x by itself on both. So what do I need to do for both situations, the x by itself? Everybody's getting 2 subtracted, right? So therefore, my ending results, I didn't mean to put the line there, would be x equals positive 3 and x equals negative 7. Do you remember doing this? Yeah. Okay, so that's how you would do it algebraically. Now we're going to talk about it graphically. How does it look on a graph and how do you solve it graphically? Okay, so graphically, you're going to think about your absolute parent function. Your absolute value parent function starts at the origin, right? 0, 0, and it has a slope of 1 on both sides. Yeah, remember that guy? All right, if it says plus 2, what happened to the parent function? There we go. It went to the left because our x's are what? Liars. So we went 2 to the left. Okay. No other change took place, right? My slope didn't change. I didn't go up and down. I just went to the left. So from here, I'm just going to rise, run, rise, run, rise, run, rise, run, rise, run, run, run. All the way up and repeat. Okay. You felt the need to finish out the song? Okay. All right. I'm going to do my very best to draw lines. Ooh, 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 ooh. No, no, no. I tried it. Thanks, Bella. All right. He actually likes Deasia. All right. So then that's done. Now we're going to graph our constant. Your constant, what does that look like as a graph? A constant is a straight line, a horizontal line, right? So my horizontal line going through 5. Okay. Your solution is where these 2 lines intersect. Where do they intersect? At -7 and 3. Oh my gosh. The graph matches our algebra? You don't say. Okay, do you remember this? Ringing some bells? Remember the graph? Oh, okay.
Yeah.
All right. Huh? Because it's your second time hearing it. When you hear something the second time, you usually process it better.
I don't know. That don't work for me.
All right, so we're good. All right, now let's talk about it here. When I have absolute value of x equals -2, well, when I break this down, it's not going to work. Can someone tell me why it's not going to work?
It would be the regular parent function, but -2 is all the way down here.
Oh, look at you, Andrew. Andrew said you would have the regular parent function, right? And it'd be like this. Pew, pew. Right? But where is -2? Below it. Are these two things going to ever intersect? No, they're not. So there's no solution. There's no solution. And the reason why there's no solution is, do absolute values produce negative numbers? No. Absolute values are going to always be positive. So absolute value is going to always be always positive. Okay? We all should strive to be absolute value expressions. Get it? Be positive. Okay? All right. So that's your visual as to why if it's equal to a negative, it's not going to work because it does not touch it. Got it? All right. We're going to look at the hardest it would get. This is the hardest it would get. Okay? Always positive. Okay? All right. So looking at this, before I do anything, does anyone remember what I have to do? I have to get the absolute value by itself. I don't want to take the absolute value out. I want to get the absolute value by itself. So what do I need to do to get this guy alone? I'm going to, remember we do PEMDAS backwards. We SADMEP. So we're going to go PEMDAS backwards. Is there anything I can add or subtract away first? Yes. So I'm going to subtract the 4. When I subtract the 4, what am I left with? Okay. Is the absolute value by itself? So what do I need to do next? Divide by -2. And when I divide by -2, I'm now left with absolute value of x minus 2 equals +3. Now can I solve? Yes. Once the absolute value is by itself, you then solve. Okay? How do I solve this?
Take the signs away and then add.
There we go. So I take away my bars. And it's going to create how many equations? And one's going to be positive, one's going to be negative. All right, I'm going to add 2 to everything. So therefore, x equals what?
Either 5
and
or -1.
There we go. Okay, that would be the hardest that an absolute value equation would get. So I'm very smart and bored people. This brings me joy. So stop being a joy killer. All right. All right. There we go. So if we're gonna check this, if we're gonna check this graphically, we gotta pay attention to our transformations, right? So the 2 tells me I went what direction? I went to the right. The +4 tells me I did what? I went up. And what is the -2 for absolute value? It's your what? It's your compression, but it's not a compression, it's a stretch, right? It's a stretch, but for absolute values, it's just the slope of the side. Okay. All right. So we're following these rules. So I'm going to go 2 to the right, 4 up, and my slope is -2. So I go down 2, left 1, down 2. Okay. And I'm going to repeat it on the same side. And that makes sense that it's reflected downwards, right? because my A is negative, which means that my graph was reflected over the x-axis. Right, Tyler?
Yes.
Mm-hmm.
I got it.
So I drew my graph. These lines are just getting worse, but just worse and worse. All right, and I need to equal what? Not 3. Why did I circle 3? -2. I don't know why I circled 3. And were we correct on our answers? Oh my gosh, we're so smart. We intersect at -1 and 5, which is what we got algebraically. Okay? Questions about solving equations with absolute value? Doable? Remembering it a little bit? Yes. Okay.